Welcome back. Coming up in this session, we have a 1 hour 30 session lined up on IPv6 implementations. We have a minor switch in the agenda that's published in front of you right now. We're going to switch Pete Stevens from Mythic Beasts to the end of the session. So we're going to run Mikael to Friso to Timo to Silvia and then do Pete at the end. Up first, we have Mikael Abrahamsson at Deutsche Telekom, who is going to be talking about IPv6 in the Terastream project. Right now, what we're going to be doing is giving each presenter 15 minutes. So, Michael, the floor is yours.
Yeah, hello. Let's see. Okay, so I'm going to be talking about the Deutsche Telekom Terastream project. We did presentations at RIPE in Greece in 2013 or 2014, I don't remember. So I thought I'd share what we have been doing since then. And the Terastream project is a project within Deutsche Telekom to do simplification of the network. What can be done if this was greenfield. So we have trying to take away as many mechanisms and protocols and support systems as needed. So the forwarding plane as where available is a v6 native forwarding in single stack. We're configuring everything with netconf and yang. Use ISIS and BDP for core routing, and we have one NMS system. And everything else is packet in IPv6 encapsulated tunnels. So for IPv4 access to the internet, it's lightweight 4/6 tunnel. I'll come back to that later. And for layer 2 services, it's L2TPv3. And also, I guess, for IPv4 and IPv6 VPNs. So towards the customer, this is single stack over Ethernet. So it's one customer per VLAN, and the layer 2 device here in the middle untags packets so that the access router, the R1, I guess some would call this a BNG, but yeah, for us this is just an access router. So it has then single tagged VLANs, one per customer. So it's one broadcast domain per customer. We support jumbo frames here so that we can do IPv4 1500 NCAP. So the resulting packet is 1548 bytes on IPv6 level, I guess 1560 or something like that on layer 2, depending on how you count the M2. We use DHPv6 to provision or to make the home router configure itself this tunnel and get other information such as NTP servers and so on. This is the DHPv6 stateless information. And we manage the home gateway using netconf as well. Today it's mainly for configuring SIP credentials and also to control software upgrade, but we already have support for getting diagnostics information out of there, and we only use that as well. So this is called system state in netconf. So we can get information on IP addresses, ND tables, ARP entries, and so on both WAN and LAN on the devices. We can also see DHCP configuration and Wi-Fi settings. We can also configure if the customer somehow locks themselves out and don't want to factory default their device. Our customer service can help them with that. So this is typically what in this kind of environment where TR69 is used. We are then instead using netconf. The home gateway is running software based on OpenWRT. So this is a combination of the vendor proprietary code for the to drive the packet accelerator and the Wi-Fi chip and so on, and also the plain old telephony system. So basically the legacy telephony ports we have on there. and then our vendor gives us a compilation environment, and then we put sysrepo on there to be able to manage it using netconf. So the device has a native IPv6 packet forwarding acceleration, and it also has full acceleration support for lightweight 4/6 tunnel packet, NCAP, DCAP, NAT that we're doing in this tunnel. So we have so far tested this on Broadcom 63138, and we have also a MindSpeed Freescale SoC that does the same. As I said before, we're using sysrepo for netconf yang management. So we then have plugins to that one that actually implements the support itself. So that more information can be found there. Over time here, so we have standardized all the mechanisms and protocols that we're using here in the IETF, and we've been trying to get open source implementations of this. So both for management and whenever we have been involved in something in OpenWRT and so on. So here is a slide that describes the data plane. So the home network, it's native IPv6 to the access router and then to the core router, and then the AFTR, which is an address family translator, sits in the data center. So this is a regular high-end server in the data center, and we have tested this. We get very good performance, 10 gig forwarding speed with 4 million customer binding entries. So this is one per customer. So it's basically saying the IPv4 address and port range that the customer has. So these performance numbers are with that binding table size, and we're seeing that this can be scaled up to support larger ones. So we also have the same NMS that then using netconf to change the settings, so basically on the AFTR to the binding table, and we're then using sysrepo and a plugin there to talk to the configuration option of this AFTR, which is part of this implementation in Snab Switch. There is a link there below. We're also using XOBDP because this is an Anycast setup. So we have multiple of these. They can be taken out of service if need to, basically hitless. And we also have a self-test so that it can itself take it out of service if it decides that it's not working well enough. On the client side, we're using D2P using option 96, which is standardized in RFC a few years back, which then provisions the IPv6 address for the tunnel endpoint, and then the IPv4 address and the range of L4 ports. It's also possible here to provision a full IPv4 address, which means that there is then no translation at all and everything works. Otherwise, you only get a range of port and a range of basic layer 4 ports, and then depending on how things are done, you might get into problem with protocols that are not L4 protocols. So, for instance, GRE, some Windows VPNs use GRE, for instance. We're also working on, in conjunction with to have a netconf yang standardized model to configure this using netconf instead of DHCP, but that is not done yet. So we have been using several different ways of doing this in DHCP over time. First, we had a proprietary experimental code point, and then there are 2 standardized ones, but we've chosen to use option 96 here specified in RFC 7598. It's possible to connect to our network just by taking an OpenWRT 1505 or 1701 adding the map package, and then just hooking it up to our access. Then, of course, we can't manage the device, but it's standardized enough for quite a while, these protocols, that that just
Questions
works.
for Mikael in the chat, please. I have a very brief question.
So that
maybe
was
while
my
other people
last
type,
slide.
but I'm interested in the
Any
size of the
questions on this?
IPv4 port ranges that you were setting. Like how much port space are you giving clients, and how much experimentation did you do with that?
So we started off by doing 1024 ports, I think. So right now we don't have a huge deployment, so we actually went back to full IPv4 address. But we've been doing tests over time with 1024 ports. I would recommend to not go below that. But we don't have a huge experience with that, but that's just from my interaction with others who have been looking into this, and so I would recommend in the neighborhood of 1,000 to 4,000 ports per customer if possible. Right. Yes, I see that one. Yes, we are doing prefix delegation, and we are actually supporting I actually made a configuration mistake initially, so I've remedied that in the version we're running out now. So we support sub delegation to customers behind our home gateway. So so yes, they can do that. We already have. I've done manual configuration changes for 2 customers that have tested that. So this is actually a standard function with OpenWRT 1505 and later, Mikael, that it supports this. So we do sub PD delegation within the home. Yes.
He wants to talk about HomeNet.
Jordi is typing. I don't know if you want to give him 5 seconds more.
Awesome.
Okay, HomeNet. Yeah, I know. Okay, so thanks everybody, and
excellent. Yeah. So next up we have Friso Feenstra from Rabobank, who's going to be talking about IPv6 success story.
Well, success story. Little bit. Presentation is called Rabobank IPv6 and what happened after. It's something of a follow-up of the presentation I gave at the RIPE meeting in Budapest. That was now almost a year ago, and this is a bit of an update on what happened after that. Oh, this is in Dutch, so let me quickly translate. The girl saying, "Hey, Captain, shouldn't we do something about that?" And the captain says, "No, it's still far away. And what's out there, it's the IPv6 customers." So for everybody who didn't see my presentation at the RIPE meeting in Budapest, we had at Rabobank an initial investigation in 2014 with 2 questions. Is IPv6 needed for our external website? And is IPv6 needed for our internal website? So do we have to do something with our IPv6? My first idea was, nah, IPv6. I've already had killed some other plans on technology to implement. So I thought, well, let's see if we can kill this one. We'll save us as a network department a hell of a lot of work. After all, private internal, we've got enough IP space using private IP space. We've got the /16 for our external, should be good enough. We do NAT, and for the rest, we're a bank. We can wait. Still I did the investigation because I did get a nice project to do an investigation. And if you get a budget for an investigation project, why not do the investigation? And what we found is that we can see that the ISPs, they are rolling out new networks. They don't have enough IPv4 space for the new networks, so they're using carrier-grade NAT for these new networks. And from what I've heard so far today, that's also what is actually going on. But beside the carrier-grade NAT, they also do the IPv6 to avoid massive translations with big content sites. So if you also deploy IPv6 to the customers, and for the most of the big content sites like Google, Facebook, YouTube and all that, transmission will go over IPv6, and that saves in very expensive carrier-grade NAT boxes. They don't have to be that big anymore. So my question was to the organization, is it a problem? Will it be a problem for us if this is going to happen at ISPs, that incoming customers are using carrier-grade NAT and don't have a recognizable source IP address anymore? Or in other words, is it a problem for enterprises that the quality of the source IP address, if they're only using IPv4, will degrade in the coming years? And then it was this time the banking security department which said, yes, that is a problem, because source IP address is a major, a key element in fraud and phishing detection. To give you an example, one of the things Rabobank is facing is DDoS attacks. And one of the things they do on a DDoS attack is that they identify the IP address where all the traffic is coming from, and if possible, they just block one single IP address. Well, that's good if that is a single user with that single IP address. But if it's a carrier-grade NAT IP address from an ISP, and there are a couple of thousand users behind that, before you do block that IP address, you have to be very careful, because before you know it, you're DDoSing yourself. And then we have the advantage, if the ISP is also providing IPv6 and we enable our external website on IPv6, then the customer will come in over IPv6 with an IPv6 unique address, and the customer is recognizable again. So that was a big success. That was at least the success I mentioned last year, and as a result, Rabobank now has an external website reachable over IPv6. And with that website, the external source IP address is handed over also to the internal applications, which do things like fraud and phishing detection. And with those source IP addresses, they can protect customer traffic. Current situation. We have it. Have the IPv6 on our external websites for IPv6, and we have plans for IPv6 on our internal network. Main reasons for that: prepare for IPv6, because IPv6 will be the leading protocol on the internet in a few years. As we have seen in previous presentations, we are currently globally at about 20%. We're growing currently around 10% a year, so in 3 years it is 50% IPv6 globally. If you look at Facebook US, it's already over 50% at this moment. And main technology companies, specifically if it comes to new developments, new features, new options, will first, and maybe at the beginning only, be deploying it on IPv6, specifically if that is the leading protocol. So new features will be on IPv6 first, And if that percentage is growing from 50 till 80 till 90 to 95%, there will definitely be features that will be IPv6 only. Now the question is, when will those features hit your local company? When will the enterprise be faced with features developed by Microsoft, Oracle, Red Hat, which will be available only on IPv6? We don't know. And that's not so bad, but the main problem there is that the lead time that we get for these protocols, so an Oracle saying this is a new feature, and by the way it's only available on IPv6, the lead time these vendors give for these new features is normally something like 6 months or a year. And an implementation of IPv6 on the internal network will take about 3 to 5 years. So there's a problem in terms of lead, and that's the main reason for implementing it on our internal network, that we will be ready for things like that. As a result, no project, because this business case is not clear enough for our management. And a lot of other projects have much more direct attention and clearer sponsoring. And there's always a contention for network projects. There are always more important network projects to start. The main path of our organization is to put as much as possible in the cloud. And so all the on-premises implementations currently have less attention. And of course we had a lot of reorganizations, and then of course reorganizations are now quite common for enterprises. So what's next for Rabobank in the wonderful success story? Next strategy we have is to sneak it in. IPv6 is normally not a CIO decision. It's just a network feature. It's something like BGP or BFDs or other network things. You don't go in a bank to a CIO saying, I want to use BFDs, or I want to use BGP, or I want to do... It's a network feature. So it's the network department that should make it available. And the best way to make it available is through an LCM project, a lifecycle management project. If you do a change on your core network, that's what we're doing, also make it enable it to route IPv6. If the server attachment core is being LCM'd, enable IPv6 as an option for the VLANs. And make IPv6 available for test segments so that the platforms can gain experience. Currently all platforms say, well, yes, the platform can do IPv6, Windows can do IPv6, Linux can do IPv6, but there's nothing on the network, so we don't allow it. So start allowing it. And things like ask third parties if they can connect over IPv6. If they can, then that's a good way to start implementing it on the third-party connections. Sneak it in. Don't make it into a big hassle. Just say, consider it as a normal evolution of your network. What we've seen so far, what is currently blocking most of our IPv6 deployments, and that's rather disappointing, I think, that a lot of cloud services that we're now moving towards are also not IPv6 ready. We're thinking currently of Zscaler mail and content gateways. Well, they don't support IPv6. Akamai is very good because Akamai on the front end supports IPv6, but the backhaul towards our data center is IPv4 only. The support provided currently by the main cloud providers, that's IPv6 limited. If you want to do nice prefix delegation and subdelegation, not on those cloud providers. And we're very watching currently at SD-WAN, and in SD-WAN not a single SD-WAN provider currently supports IPv6. So on the cloud services, it's a bit disappointing. Conclusion. First of all, treat your external and internal implementation separately. They do have both very different reasons. Main reason for external, quality of customer source IP addresses. And that can be either for security, but it can also be a commercial thing. If you want to keep on tracking your customers for commercial reasons, ensure that you, if the customer is behind carrier grade net, go to IPv6, you'll see your customer again. If you can find a good business case like that, use it for a corporate project. If not, sneak it in with limited visibility. Just call it a network feature. So that when a real requirement arises, and you already have sneaked it in here and there on a number of places on the network, you'll be in a much better condition to put it in, specifically if you only get a 6-month lead time to implement it. Well, that's about it. Any questions? Any questions on the moderator side?
So questions in the chat, please, if people have questions. The last 2 comments in the chat are that people seem to be very happy with slide 11. We're very interested in slide 11, perhaps. I did have one question, which was I like the message, and I think it makes a lot of sense. Do you have any particular examples or cases where the quiet expansion of IPv6 led to the discovery of a bug or a network configuration issue that forced a rollback, and therefore concerns about that IPv6 rollout going ahead in the future? Like, did you hit on any problems as you went out that
no, currently we're sneaking it in very carefully and very controlled. So fortunately, we haven't hit that problem yet. But I'm sure that we will have little outages, and then we have to come to the management and say, and they'll ask, what did you do? And then we said, well, we were implementing a network feature.
Right.
And management is normally not interested, as I said, in the actual technical details.
Sure. We have one question in the chat. Any pushback on the LCM route?
Is that a question to me or?
I assume so. It's not to me.
I'm not currently, don't understand the question exactly. Is there any pushback from management?
Any pushback on the LCM routes? Already answered, apparently.
Okay,
so, and do you plan on running IPv6 only in the near future, at least internally?
No.
Then that's easy.
Definitely not.
Okay.
I'm already happy with it, and if I can sneak it in on most of the network, and then once the whole network is working it, and that is all nice and stable, only then very quietly will I come up with the next message to the internal audience saying we're going to disable IPv6 on specific networks, but that's already quite far in the future.
Cool. Awesome. Okay, I think that ends the session. Thank you, Friso.
Okay, thank you.
And our next speaker is Timo Hilbrink, who is at XS4ALL and has been there since 1997. I read in his bio. And Timo is going to be talking about 16 years of IPv6 at XS4ALL.
Okay. Hi, my name is Timo Hilbrink. I work as a network engineer at XS4ALL. I've been doing for a while. Since the session was kind of celebrating 6 years since IPv6 launch in 2012. I thought, well, why not take it a bit further, because we are actually doing 16 years of IPv6. Of course, that was not straight away full-fledged IPv6, because that wasn't there. So I want to take you through a bit of the history of what we did and how we did it. First of all, X4ALL, we're, for the people who don't know us, one of the first Dutch ISPs founded by a bunch of hackers in 1993. We were acquired by Deutsche Telekom, and yeah, we run the usual services that an ISP does. So in 2001 we got 6bone space. Some of you might still remember that IPv6 project for experiments. Not really IPv6, but kind of. We ran that. We had prefixes, some prefixes there, and we started running a tunnel server with that. And around the same time, we got the IPv6 prefixes from RIPE as well. So we ran a tunnel server since 2002 in production, and people could do their IPv6 over v4 tunnel on that. So that was actually for us the first time we started experimenting with v6. We also added IPv6 access to a Usenet server. We have a big Usenet server. It was read-only access on IPv6, and that generated quite a lot of traffic because a lot of people wanted access to a Usenet server. And in order to do so, they had to set up an IPv6 tunnel and stuff like that. So that generated some nice traffic, so we could work and we could, you know, set up our backbone and all that sort of stuff. Stuff that you need to run IPv6. That took a lot of time because a lot of equipment that we had was definitely not capable of v6. So in our backbone, we used the next couple of years in our backbone to enable stuff and upgrade where necessary. Then in 2010, we were kind of ready to start a pilot. We had some for our subscribers, actually, just to give them native v6. That was still quite complicated because the routers that we have that handle the PPP sessions to our customers, that is, they didn't completely support it yet, but we did some workarounds and some beta software, and we were able to set it up a pilot in 2010. We got I'll run you through the details of that later. In 2012, before the IPv6 launch, we enabled it for all new connections, and then 2 years later, we just gave all customers IPv6 by default. So yeah, like I said, we run a subscriber network to our customers. They have mostly PPPoE now. PPPoE is actually already phased out. Nowadays we run Juniper MX 960 for to terminate the PPP sessions and do all the stuff for that. On that we do a single session dual stack. So v4 and v6 on every connection, and we give every customer a /48 prefix. That's the way we run it at the moment. At CVEs we use Fritz boxes. We actually got AVM on board quite early, back in around 2011-12, and they were quite happy to go with us and set up IPv6 in their products so that our customers could use it. And by now, actually, all of their models support v6, so that was really helpful because otherwise we would not have been able to set it up. So the pilot actually consisted of about 300 users that were kind of techie and they knew what they were doing. On our side, it was very very basic. So we were running, like, we had to do text files for provisioning and all that sort of stuff. But it was positive and people were happy and it was working. So then 2010 we went production and we made it an IPv6 option available in the customer portal, so people could just switch it on if they wanted it. Native support was in the release software of our modems, so that was a big step forward. And then in 2012 we said, okay, this is now mature enough to actually set it up for all new subscribers. So everyone who signed up for a new connection, they got it straight away. Then in 2014 we said, okay, this is now really, like, we have no problems, we had no issues. Our support desk, a lot of our support people weren't even aware that we were enabling IPv6. We did it kind of sneaky, like Friso was saying as well. So a lot of people didn't know, a lot of our customers still don't know, but it doesn't matter, that they don't have to. It's you know, if it works, they don't need to know. And currently we have about 200,000 active IPv6 subscribers. Basically everyone has it enabled, but some people choose to disable it in their modem, or they hook up their own CPE or modem or whatever, or router, and that maybe might not support v6. So those are not in that in the number. So that's about 200,000 connections. In the meantime, of course, we slowly started enabling v6 services on all our services that we provide. So, you know, mail and voice and webmail, colocation, all our DNS infrastructure is all v6. Our customer portal is, and we just more or less said everything that we set up now has to be v4 and v6. So otherwise, it will not be introduced. That's all those numbers that gained us. If you look at the statistics for IPv6 in the Netherlands, it's lonely at the top, as they say. From the big ISPs, there is one more in there, KPN, which is actually our mother company. They're slowly gaining. They're at about 27% of IPv6 preferred. And the rest is really not in there, unfortunately. They're yeah, missing out. So a lot of people ask me, like, you know, you have a lot of IPv6 customers, but, you know, is it actually used? I mean, is there any traffic? Like, is it just a feature and nothing is happening? Well, people do use it, yes. About 30 to 40% of all our traffic is v6. So as you can imagine, a lot of that comes from the big companies, like the Googles of this world. That also means that you have to make sure how your traffic flows. You know, v4 and v6 traffic might not follow the same routing policies. There might be different paths for connectivity. And like some of your peers might not have good v6 connectivity, so suddenly you might end up seeing v6 coming in over transit while v4 is coming in over peering, all that sort of stuff. Also, your transit providers, of course, they need to be able to support it. Nowadays, that is pretty standard, but over the last, well, say 10 years that we're doing this sort of stuff, we ran into issues that you wouldn't have expected. And of course, your CDNs, a lot of ISPs these days have a CDN in the network to kind of bring the content closer to the customer, and that also has to be v6, otherwise your CDN is kind of useless if everything's pulling in over v6 and not coming from your CDN. So the customer issues that we come across, that our support desk comes across, is this sort of stuff: third-party websites not configured properly, so they have their, you know, the setup of the web server is not correct. So, you know, the v4 is actually configured as the website, and v6 you get the default Apache website, all that sort of errors. This actually came across this week. The local tax office turns out to have a sort of a website where the employees can log in for you know, internal work stuff, and that's the IPv6 part of that was enabled but didn't work. So the tax office employees that have a connection with us, which there are apparently quite a lot of, they couldn't reach their internal work website to log in for certain work-related stuff. And the tax office help desk told their employees just to disable IPv6 in the modem, because that would kind of fix it. Of course, it would have been the other way around, and they should have fixed their setup. I think that in the meantime they have, actually, but that was just a recent issue. And you know, you can do these sort of pages where the web server is not set up correctly, or you know, this is what we get, and then we get our support desk get people on the phone and say, like, it works for everyone, it works on mobile, it just does not work with you guys. Every other that we tried worked, and yeah, that's correct, because all the other ISPs, as you've seen, they don't have v6. So yeah, that's a clear explanation. But that is the only thing, actually, the big thing that our support desk comes across. So over those years, what are the lessons that we learned? Of course, you start with creating an address plan. That's very important if you're doing v6, especially because you got a big bunch of space, and it's a good idea to make a good make good segmentation in that and make it easy to understand and clear where things belong. try to create a friendly user group to get some people on board that know what they're doing and give you decent feedback. Take plenty of time to deploy, small steps at a time, like Friso was saying as well. Just start with small things. Every time you upgrade something, every time you replace equipment, make sure that it does v6, and don't make too much fuss about it. Just go small steps at a time. And you need to educate your colleagues and management. Management might not have to be the one that says, okay, we're going to do IPv6, or sometimes it is. But it is important that they say the reason why you do it and the reason why you find it important. We did not do it because we needed IPv4. We were running out of IPv4 space. We did it because we thought it was important for the optimal experience of our customers to give them the optimal experience on the internet. And of course, you need to train your support department, like I showed you the examples that we come across. They need to know what it means if customers start complaining with these sort of errors and what needs to be done. And of course, you need to review your peering agreements and transit stuff. For like last slide, I want to rename the company. I've been wanting to do this for a while, but management still doesn't agree that is a good idea. I don't know why. I think it's marketing or something. Anyway, that is it for me. Thank you very much, and I'm open for questions.
Okay, thank you, Timo. Questions on the chat, please. I see a long question. IPv6 is a public address accessible from the internet. What is your opinion? Should ISPs, parenthesis, mobile providers, do to block incoming traffic to potentially dangerous ports? Maybe I can summarize that as, do you keep your lines completely open, or do you firewall inbound traffic to customers?
What we do is actually the CPE that we supply by default has everything closed, so it acts like a feed4 with NAT. So its default, everything is blocked and the customer can open ports himself. Globally, blocking these sort of ports in our network is not allowed in the Netherlands anymore because of network neutrality regulations that have been put in place. But we do set up the Fritzbox, but to default block all incoming v6 traffic, just like it would be as a NAT box. And that's what people expect. So.
The one other question is, do you monitor customer access, bandwidth, or latency? I guess that's performance metrics. Do you see
differences? Yes, we do absolutely do that. We do see very little difference between v4 and v6 these days. I mean, there used to be quite big differences because the peering transit landscape was not really up to scratch. But like I said, these days almost anyone that we peer with has v6, and the ones that don't, they just say like, we don't do v6 because we think it's not necessary. So like, well then, but you know, the most of the stuff is dual stack. So yeah, we don't see much difference in latency or bandwidth performance.
Okay, I think if there are no more questions, I think, well, there's a question. Do you provide v6 connectivity to IoT providers? I'm not sure I understand the question, but maybe you do.
If yes, who is responsible? Yeah, we don't. Yeah, we are a residential provider, so I don't really see what you mean with Internet of Things provider. I don't. Yeah, I don't know.
In that case, thank you, Timo. I think that was an interesting talk.
Thank you very much.
Okay, next up, we have Silvia Hagen, who is the president of the Swiss IPv6 Council. And she's going to be talking to us today about the status of IPv6 in Switzerland.
Well, hello everybody. I'm Silvia from Switzerland, and I am a consultant for IPv6 since many years, book author, and I run the Swiss IPv6 Council. So I was asked to do a little overview of what's happening with IPv6 in Switzerland. So first of all, just to give you an overall impression, that's graphs taken from sixlab.cisco.com, and we see the user adoption in Switzerland. So we see it started sort of in 2012 a little bit, but then in 2013 it jumped up to 10%, and actually Switzerland was #1 worldwide in user adoption in 2013, until the Belgians took over in 2014, and since then the Belgians are #1. But we're following them. And so today we are approximately at 30%, a bit up and down. I actually don't know what those interesting peaks are. I will have to find out. That go over 30%. So, but the average is 30%. And I must say that this is mostly Swisscom customers. Swisscom has done a big deployment. They use 6RD, and I'm just going to talk a bit more about Swisscom. And everybody else is a little bit asleep. There is UPC who does some deployment, but they do IPv6 with DS Lite. And as far as I know, they only deploy it for new customers. And that's why there is not this big thing. They don't migrate their older customers. So that's what comes to user adoption. And then even the same from the 6Lab side, we have Top Alexa 500 Swiss websites. So these are websites that are visited from Swiss customers, and it's about 127 websites out of 500. So a bit more than 20%. And so here I got a little update from Swisscom. I just got this information last week. They have a new IPv6 only network for aggregation of DSLAMs, and that is something that will not be visible to customers. Then they run dual stack now, or they implement dual stack on their BNG. That's their border network gateway. So it's the customer access routing platform. And they introduce support for DHCPv6 PD, so prefix delegation for CPEs. And according to their plans, this migration should be completed by mid-2019. And then it will also be available to wholesale ISPs, such as, for instance, Sunrise. Their standard CPE box learns DHCPv6 prefix delegation on the LAN side, and this is for this year. Their mobile group works on dual stacking the internet over the mobile network, and they start this year, and the migration will take some time. So their goal is to turn off IPv4 in the mobile core, which also is not visible to customers, but important for the internal operations. And then voice over LTE is IPv6 only since the beginning. And the LAN group finally is continuously integrating IPv6 in products and IT systems. Then I checked the status with the Swiss government. They actually started pretty early back in 2008 with working on their first strategies, early strategy and address planning. Since 2015, they have a /27. And the army, like the VBS, has its own allocation, so it's not part of that /27. Currently, they focus in redesigning the national addressing concept and integrating all the cantone as sub-layers so that the cantons will be ready to start their own projects. In 2019, so next year, they will reinitialize their own planning, their conceptual work, and create a strategy and a roadmap. If you want to check the status of the websites of Swiss government sites, then you can check our dashboard. You see the link at the bottom of the page. I did not include a screenshot. It looks pretty sad. Which is okay, everybody can make his own choice, but the problem here is that I pay it with my tax money. And in Switzerland, the e-government and IoT people have not discovered yet that all these things will not take place with IPv4. So there is still quite some work to do in this area. When it comes to organization, so I must say this, I did not have the time to make a big assessment of what's really happening in Switzerland. So what I mention here is just a few things that I'm aware of because I'm either working with these customers or because I know about it in my function as a president of the council. So two organizations that have started the walk pretty early is the Swiss Post, and with it also Post Finance. So Post Finance offers e-banking services over a dual stack website, and I use it regularly, and it works. Then we can book our travel tickets in Switzerland over IPv6 because SBB is the Swiss train company and Swiss is the airline company. Actually, I just realized today that currently they have a problem with IPv6. So right now it doesn't work, but it's been on, as you can see from the screenshot on the right side, the bottom screenshot. Then Six Group is pretty interesting to me. This is a project we started recently, and the reason for them to start this project, so Six Group, I must say, is like at the core of Swiss financial industry, and I like it a lot that they're moving. They do the whole interbank clearing in Switzerland, and the reason they're rolling it out is because they have to totally renew their access platform due to end of life. And they said, okay, if we're going to renew this in 2018, we're going to include IPv6. And they're moving ahead pretty quickly and pretty good. So that's a good message. Then I know that most insurance companies are working on concepts, but they are usually like many other companies, enterprises, they are just in the status of planning, roadmaps, address plans, and stuff. They're not really deploying yet. They're sort of getting ready so that they can deploy when the need arises. Then we have Coop starting with a project that's like food and wholesale. We are working on Swiss TV because that's quite a lot of traffic with all the streaming, and they are an Akamai customer, so actually should be pretty easy. We just didn't find the right person yet that can make the call to Akamai. And the Swiss media, they are in a deep sleep state, even IT media, which I think is a bit sad. And I was actually last year talking to one of the IT managers of one of the two large media houses in Switzerland. I said, tell me what I need to do in order to, so that you enable all your websites for IPv6. And he said, if you can prove to me that IPv6 makes it 200 milliseconds faster, I'll do it. I get a business case and I get money. So now I'm still looking. I did some measurements as consequence to this statement, but it was not obvious enough that IPv6 would be faster. I mean, there's obviously many things that have an impact on performance. So, but once we get there and I see that the comparison between IPv4 and IPv6, IPv6 gets slower and slower due to probably all the CGNs that are now being built. So maybe next year I can go there and say, hey, listen, I can prove it to you. So that's just a few that I know, and I'm sure there are many more. I know that some of the chemical industries companies are working on it, and there are many others that I just don't know about. But my gut feeling is that in Switzerland it's happening. When you talk to Swisscom, an average dual stack user has like 30% of traffic over IPv6, which is pretty good. I think we made it. And to me, it's like we can sort of relax in a way that companies that don't work on it, it's their problem. They will pay for this at some point. I think the IPv6 internet has sort of taken off in Switzerland. So that was it from my side. Thank you very much. And if there are any questions.
Questions in the chat, please. So you sound pretty confident that the Swiss v6 internet is there. So you can sit at home and you can disable IPv4 and you can access most of your Swiss content. Is that reasonable to say?
I would actually not really turn off IPv4 yet.
Right.
And the statement, I think, is not just for Switzerland. I think that's like an average statement, which would also be true for Germany, or even more for Belgium. I don't think we're at the point where we can like turn off IPv4, but I like the way many are going to sort of treat IPv4 as a service. So like the mobile stuff happening in the United States with XLOT and the smartphones just having an IPv6 address, that's possible.
So you mentioned the Swiss television folks. Maybe an interesting other organization to talk to would be the folks at the BBC, where in a very large sense the BBC is still pretty IPv4 heavy, but they presented recently at the UK IPv6 Council, and they are doing a lot of work into IPv6 deployment and content delivery.
Swiss team.
Of course, yes.
Okay, I'll talk to Veronica about that.
Precisely. I think that would be a good conversation to line up. I don't see any other questions on the chat. Oh, there is. Are there any plans to release the next edition of your books?
Oh, that's a question. So you know that I have like 3 books. One is, there is IPv6 Essentials by O'Reilly, which is in its 3rd edition, and there is this German companion book, which is also in its 3rd edition, that's self-published. And you know, I guess 3 times 3 is 9. That's a good number. I think the next version should be written by some young person. Not that I'm old, but just the younger generation should take over. I'm good at talking to management and making them understand that they need to spend money on IPv6. And so the young people can do the technology part.
I think you partially answered this. What is the IPv6 status on the Swiss government administrations?
Well, yeah, I'm not sure what this person wants to know, because I sort of said what they said, this is what you can say about it. Okay, and I also commented it.
I think that's us. Yes, mentioned in the slides. Okay, perfect. Thank you very much, Silvia. Our next speaker will be Pete Stevens. Pete is a director at Mythic Beasts in the UK, and Mythic Beasts have been doing some very cool work for a while, building IPv6 only backends and data centers. So I think Pete is going to be talking about how you go IPv6 only.
Right. So I'm director of Mythic Beast Limited, and we've done a bunch of stuff with IPv6. It started, next slide please, started in 2012 with World IPv6 Day. We like to think we're a technically competent bunch of people, so we'd look really stupid if we didn't have IPv6 on our public website. So we enabled IPv6 on our public website, and looking at the logs, we think someone even used it. Just one, maybe 2, and that person wasn't one of us either. So yeah, we mission accomplished, IPv6 deployed, can go home now. Next slide, please. So throughout 2012, we gradually started adding IPv6 to some of our other services. So we added it to our MX records, so we could receive mail over IPv6, which Google started delivering to us. DNS, so you could get DNS requests from us. All of our shared hosting accounts on our managed platforms ended up with v6, so you could access all of those websites over v6. But basically, all of our traffic was IPv4, and if we turned off IPv6, pretty much nobody would have noticed. Next slide, please. So, why bother was the question that was bringing us, because we hadn't actually really achieved anything. Deploying IPv6 had taken a bunch of time and had added complexity to our configuration, but it wasn't actually slowing down our IPv4 address consumption, which is sort of the point. The migration plan, which is everybody deploys dual stack. Sorry, let me turn that up. Everybody just deploys dual stack, and then when everybody has dual stack, we can deploy a v6 only device, was basically rubbish, because that means our advantage from having v6, which is not having to consume our v4 addresses, still is nowhere near viable. Looking at the graph, it was looking anywhere between 5 to 100 years for dual stack to become deployed everywhere, and we were going to run out of IPv4 addresses much before that would happen. So we need a better plan. Next slide, please. So we decided we were going to try and deploy an IPv6 only service, and the only one we could think to deploy initially was our IP6 health check page. And this basically is a VM that has only v6 connectivity. It's completely single stack to v6, and you can go to it and request it try and fetch your website, your email, and your DNS, and it will complain if it can't do everything in a completely pure v6 environment. And our marketing department, i.e. me, decided that we should make this public so anyone can use it. And we now have quite a lot of people who use us as a check to find out if their v6 implementation works. Next slide, please. It's harder than you think to get a perfect score. Google is currently 10 out of 11 because a few of their mail servers appear to be missing reverse DNS, which is one of the things we check for, because Google will throw your mail away if you don't have reverse DNS. Next slide, please. So once we got this up and running, we then ran into the immediate difficulty that what we mostly do is manage servers for people. And half of our management tools didn't really work with an IPv6 single stack server, which was powering our IPv6 health checker. And so this involved various bits of going through our control panel and our automated setup things, and deleting various assumptions like every server has an IPv4 address. You know, if you look up an IPv4 address, you may get null back, and you have to cope with that. So the first thing we had to do was give native v6 to our backup server so that we could actually back up our checker. All of our monitoring, we had to support v6 literals, so that you can say, you know, ping this v6 address and make it so that it connected out over v6. This turned out to be, in many cases, a really simple check that basically looked for a numeric type address and put square brackets around it in order to make our v6 checks work. Next slide, please. Cool. So the next thing that follows on is suddenly your management services are now connecting over v6 by default to servers that had them, so you need to go around and sort out all of your firewalls so that you can connect over v6. Our munin configuration, again, another hack to put square brackets around things. A bunch of our stuff is written in Perl. We're very sorry, but at least it wasn't PHP. And Perl won't connect out over v6 at all until you install the Socket 6 package, which confused us for quite some time. And eventually we got there, and we got to the point where we can roll a v6 only service, a v6 only server, and every single one of our management tools will work as it does to a v4 server. So complete feature parity between v6 and v4. Next slide, please. So, next thing to do, sell it. Let's try and sell servers that don't have an IPv4 address. And you discover that, unfortunately, all the people who say there is no customer demand for v6 are correct. We sold a handful, virtually none, so wasn't helping to deal with our v6 depletion, and mostly the people who bought them were other network engineers attempting to v6 test their own network, which is not quite the same as an actual kind of useful public service. And at the time, global v6 usage was reaching 1%, which was obviously nowhere near good enough for this to actually be viable. So again, we've done a bunch of work and we've concluded that we've not actually really achieved very much. Next slide, please. Finally, we found a real production use case. We host Raspberry Pi. It's quite a popular website, aiming to teach computing to kids by giving them their own very, very cheap computers. It turns out what bored teenagers do is denial of service things, and one of the things they chose to denial of service was us. So the way we resolved this was pretty simple. We spun up a bunch of machines in front of Raspberry Pi that acted to sync the unwanted traffic, and then removed all the v4 addresses from the back-end server and just proxied all the web traffic through. This has a really nice advantage, which is it's really hard to DDoS a server if you can't route to it. So, a production usage. Unfortunately, the production justification is IPv6 is really good because it's so rubbish even script kiddies won't use it, which is not really the kind of sales and marketing message you want to use. But it kind of made us realise that actually we'd inadvertently deployed a real production website that wasn't consuming v4 addresses on the actual servers to do it. Next slide, please. So, IPv6 only backend servers. This turns out to be really useful. So what you can do is you spin up a server that only has v6 on it, In order to be any use, it needs to be able to talk out to other things that are v4 only, like Twitter, for example. That's a very popular one that people want to fetch data from. So you need a NAT64 proxy for outbound traffic, and you need another proxy for inbound traffic, so that people on v4 only services can actually view your stuff. So we implemented HO proxy to sit at the front end. Where this all goes horribly wrong is, at the time, every SSL site needed to be on its own IP address, which means we're still back in the problem that we're consuming IP addresses really quickly in order to supply the services that we're selling. Next slide, please. Windows XP to the rescue, not something you hear very often. In 2014, Windows XP went end of life, and Windows XP was the last major kind of bulk of users that didn't support SNI for SSL, which means you can share IPv4 addresses for your SSL traffic. So we decided that SNI was now production stable. We could just use it by default for an awful lot of services, which meant that we could proxy HTTPS, we could proxy IMAPS, we could proxy POP3S, any SSL service is enabled. We took the view that if your service didn't support SSL, it should. This is the modern internet, please don't complain. And when we got Windows XP users who said that they got and didn't get a padlock on their website, and it said that their web connection was insecure, we said, that's correct, it is. You need to update Windows XP to a new operating system to fix that. Yeah, that one actually bailed us out of how to get efficient v4 address sharing for lots of different backend servers. Next slide, please. We now have a production-ready v6 service. You spin up a v6 VM. It has backups. It has 24/7 monitoring. You can access it over the web using SSL. It can talk outbound to other things via NAT64. The only problem now is we need to persuade someone to buy it, because our real aim here is to be able to continue to sell services without consuming our limited public v4 address space. Next slide, please. So, if you want to sell v6 only, don't say, would you like v6 only? It's a new internet standard used by 5% of the population, and you might find compatibility issues. That doesn't work. People don't buy that. Do say, would you like next generation networking like we use for Raspberry Pi to protect from DDoS attacks? And as there's no legacy costs, it's slightly cheaper. Turns out people like that, and they will agree and buy it. That's basically the approach we've taken. Would you like the same service that Raspberry Pi has for their website? That acts as a really nice case study to make it plausible to sell v6 only service to people. Next slide, please. Of course, the other set of people you have to sell to in some organisations is the technical staff, and they all know IPv6 doesn't work already. So the selling to them is pretty easy. You say, have a /64 or even a /48 of v6 space, as many addresses as you want. If you'd like another IPv4 address at any point when you're using this server, here is a form to fill in to justify it, and please send a purchase order for £20 a year to justify the additional address. This means your technical people have two choices. They can enable IPv6, or they can go and explain to their accounts department why they want a purchase order. Technical people hate the accounts department and will usually enable v6 rather than have to go and talk to them. Next slide, please. So, we've successfully sold this. We've got some technical customers, London Internet Exchange, Raspberry Pi, UK Network Operator Forum. Obviously, Internet Things who want to be pro v6, and we've got less obvious ones like Parallax Photographic, who do actual original film cameras and can sell you Polaroid film. A weather company, disk profiling software, and a whole load of others. Yeah, it's a production service, people buy it. Next slide, please. My good friends at Raspberry Pi like this slide. They sell computers that cost $5. IP addresses, according to the according to the marketplace, are now about $24 each if you're trying to buy a /24. So that's 5 times as much money to give your computer an IP address as it does to buy it. Next slide, please. So, when the Raspberry Pi 3 came out, which supports NetBoot, we built the Pi Rack, which is a cloud hosting service for Raspberry Pis, which looks a bit like that. Next slide. Each block consumes 4 U of rack space, has 108 Pi 3s in it, which gives you 108 gig of RAM and 432 cores. There's just one wire to each Pi, and they consume about 2 to 3 watts each. Next slide, please. The network plan was really simple. We give them a /30 of private space so they can net boot, and then we gave them a tagged VLAN with a public v4 address and a public v6 address, which is a nice idea, but doesn't work. If the boot ROM sees a packet from a tagged VLAN, it crashes. It's really hard to sell computers that don't boot. So you'd really need to do this with a /30 of v4 space, and that means you're looking at the best part of $100 of IP space to turn on a $35 computer, which is getting really silly, particularly when your v6 space is 3. Next slide, please. So we decided that this was all horrible, and as this is an educational setup, we want to do it right, so we don't want to have crazy proxy ARP hacks or /31s or anything like that. So we decided that we were just going to go v6 only in our iCloud. It doesn't support v4. When you buy one, it sets up a port forwarder for your SSH access. It auto configures our 4 to 6 proxy, which forwards all SSL traffic in HTTP, and you get another address that gives you a v6 only access. Next slide, please. This is a toy computer platform at the moment. You should not use this for anything serious. It does not have an SLA. Do not expect it to work. However, customers obviously don't read any of those warnings, and we've discovered that the Cambridge Beer Festival had the back end for all of their beer rating and which beer is popular and who's drunk what was powered on a Pi 3. PyWheels is a service that pre-compiles Python for ARM, and that's done by natively compiling everything on the Raspberry Pi. And we've got a bunch of Raspberry Pi user groups who run their websites and their meeting pages on Raspberry Pis. The biggest problem we have with our Pi platform is lots of people read how to secure your computer on the internet 101 and enable a really strict IPv4 firewall. And the only thing you can firewall on the Raspberry Pi in v4 land is the file system. And your computer frequently stops working quite soon after your file system disappears. But other than that, yeah, it works. And we've got a decent number of customers running on v6 only computers on a platform that does not support v4 and will never support v4. So next slide, please. So, I forgot to put in the contact details. So yeah, that's my brief summary to v6 at Mythic Beasts. That should have a link to our Twitter page and our website, but I obviously forgot to include them. So yeah, any questions?
Well, thank you very much, Pete. Okay, the stuff that Mythic Beasts is doing is really excellent. So if you get a chance, take a look at them. I think that we are at the end of this session. The next session is starting 40 minutes from now, and that will be on next steps and the road ahead.